All right, welcome back. I hope everybody enjoyed all that snow. It's so beautiful. Today we are going to be doing lesson 5, but before we do that, I'm going to just do a little bit of warm up with you. So as I go through these, I want you to try to think through the answers before I say them. Okay, so for instance, on this first one, 10 times a half would be 10 halves, or take half of 10. Okay, you could also think about it like this. 10 times a half is 10 halves, which is 5 whole. Okay, 10 times 1/5 is 10 fifths, which is 2 whole. 8 times 1/4, 8 copies of 1/4 would be 8 fourths, which is 2 whole. 30 copies of 1/6 would be 30 sixths, which is 5 whole. Okay, switching gears. Hopefully you followed that, okay? Now, if you think about division, remember we can think about division as fractions. So if I think 9 divided by 30, I could think about it as a fraction like this, 9/30ths. Well, if you simplify 9/30ths, if you divide both these numbers by 3, you'd get 3/10. How do I write 3/10 as a decimal? 0.3. So 9/30ths as a decimal is 0.3. Let's do another one. 28/40ths. We can think of that as 28 divided by 40, like that. If we simplify our fraction, divide by 4 on the top and the bottom, I get 7/10, which is 0.7. Okay, so watch how I turn a fraction into a decimal. Notice that I have to convert it to tenths first because decimals are written in tenths and hundredths and thousandths. Next one, 18/60ths. You can pause and try this by yourself if you'd like. Okay, 18 divided by 60. Simplify, please. You divide by 6, which would be 0.3 again. Okay, last one, 63/70ths. What would I divide by here to simplify? I could divide by 7 on top and bottom, which will give me 9/10, which is 0.9. Okay, last warm up. If I have 13 halves, what's another way to write 13 halves? That is improper. How can I make that a mixed number? Remember, 2 divides into 13 6 times with 1 left over, 6.5. Okay, again, if you need to do this off to the side, that's okay. You would do that, okay? But if you can do it mentally, that would be great. 17 halves, 2 goes into 17 8 times with 1 left over, 18.5. 31/10. 10 goes into 31 3 times with 1 left over, 3 1/10. One more, 13/3. 3 goes into 13 4 times with 1 left over, 4 1/3. Okay, just a little bit of warm up today before we get going on lesson 5. So if you will turn in your blue Learn book to page 149. Notice there's no application problem today because it is a problem solving day. So let's take a look at our first word problem. Again, we're looking at division and fractions here. Okay, and also tape diagrams. We're going to utilize that quite a bit today. Okay, a total of 2 yards of fabric is used to make 5 identical pillows. How much fabric is used for each pillow? Okay, again, the key to these is deciding what is being divided. Okay, your total fabric is what's being divided up. I have a total of 2 yards of fabric. So when I think about my tape, my total that goes at the top is 2 yards. Now, how many pillows am I dividing that up into? 5 pillows. So 5 boxes. Okay, so each one of these is a pillow. 5 pillows. Well, how much is used for each pillow? That's what I'm looking for. Well, I have 2 yards being divided into 5 pillows. Okay, so 2 divided by 5, I could write as 2 divided by 5, 2/5. So 2/5 yards of fabric would go in each box for each pillow. And let's count that. 2/5, then another 2/5 would be 4/5, 6/5, 8/5, 10/5, which is 2 whole. Okay, so we used all the fabric. Okay, so 2/5 of a yard of fabric for each pillow. All right, let's look at the next one. Number 2, an ice cream shop uses 4 pints of ice cream. I have a true passion for ice cream. Look, I keep some at school. Delicious. Just thought you might like that. They're using 4 of those pints to make 6 ice cream sundaes. How many pints of ice cream are used for each sundae? Okay, well, I only have 4 pints. And notice I'm not making 4 sundaes, so you can't use a full pint on a sundae. I'm making 6. So it's going to be less than a pint for each sundae, if you just kind of think through the mental math there. Okay, but if we draw a tape, think about what's being divided. My total ice cream, which is 4 pints. Now, how many sundaes am I making? 6. Okay, so each one of these is an ice cream sundae. Okay, so how much goes into each sundae? Well, you have 4 pints of ice cream being divided into 6 sundaes. So 4 divided by 6 could be written as a fraction, 4/6. Okay, so it takes 4/6 of a pint. It's less than a pint, a fraction of a pint, for each sundae. And you could simplify that fraction if you wanted to. 4/6, you could divide each of these numbers by 2, so that would be 2/3 of a pint. You could have simplified. Okay, hopefully so far so good. Again, another ice cream question. I love it. What's your favorite flavor? Mine, chocolate peanut butter is quite good. Okay, an ice cream shop uses 6 bananas to make 4 sundaes. How many bananas are used for each sundae? Use a tape diagram to show your work. Okay, and if you think mentally through this a second, you have 6 whole bananas and you're only making 4 sundaes. So each ice cream sundae would get a whole banana, plus you have 2 bananas left to divide between those 4. So you could give another half to each one. So you could think through that and say each sundae gets a whole banana plus a half of another one, 1 1/2. Well, let's see if that works with the math, which it will. Okay, so if I draw myself a tape, and my total is 6 bananas is what's being divided. 6 bananas. And I'm dividing it into 4 sundaes. Here's an ice cream sundae. I've got 4 of them. Okay, how many bananas go in each one? Well, I have 6 bananas being divided into 4 sundaes. 6/4. Well, that's improper. Okay, 4 goes into 6 one time with 2 left over. 1 2/4. Or you could also simplify 2/4 to a half. So 1 1/2, and that's what I said at the beginning, wasn't it? 1 1/2 bananas for each sundae. Okay, and they told us to use a tape, but you could have drawn pictures and thought, okay, here's a banana. I'm not an artist. Here's a banana. Oh my goodness. This is a sad illustration. 1 2 3 4 5 6. Okay, 6 bananas. Well, I'm making 4 ice cream sundaes. So here's my sundae cups for my ice cream. Okay, well, each sundae would get a banana, right? And then I have 2 bananas left. Well, if I cut them in half, then each sundae would get another half a banana. So they each get one whole banana and half of another one. Okay, enough of that. On to the next. Hopefully we're doing okay so far. Okay, number 4. Julian has to read 4 articles for school. He has 8 nights to read them. He decides to read the same number of articles each night. So how many articles will he have to read per night? Okay, well, notice he doesn't even have to read a whole article a night. If he only has to read 4, and if he read them in 4 nights, it would be 1 per night, but he's doing it in 8 nights. So it's not even a whole article every night. So if you're drawing yourself a tape to show this and say, okay, I'm taking the 4 articles and I'm dividing them up into 8 nights. Okay, so a box represents a night. Okay, so 4 articles are being divided into 8 nights. 4 divided by 8, 4/8. If you simplify that, it's a half. He only has to read 1/2 of an article each night. Notice the math on these is not hard, but you have to decide what's being divided and what it's being divided by. Now this question, don't overthink it. It says, what fraction of the reading assignment will he read each night? Well, the whole reading assignment is being divided into 8 nights, so he is reading 1/8 of the assignment every night. 1/8 of the assignment each night. Okay, so it has nothing to do with the length of the articles, but it's just saying, well, if you divide the assignment into 8 nights, he's reading 1/8 of the assignment every night. All right, number 5. Oh, another thing I love so much, pizza. 40 students shared 5 pizzas equally. How much pizza will each student receive? What fraction of the pizza did each student receive? Okay, well, again, what's being divided? The students or the pizza? Okay, well, the pizza is being shared equally. Okay, so when you draw your tape, you're dividing up 5 pizzas. Okay, among 40 students. Now, I'm not going to draw 40 boxes here. Okay, so a lot of times if you do that, you could kind of number and say ... 40. Okay, so you're indicating I'm 40 boxes go on my tape, but I'm not drawing all of them. Okay, so I want to know how much each student gets. Okay, we'll have 5 pizzas being divided among 40 students. 5 divided by 40. You could think of that as a fraction, 5/40ths. And if you simplify, divide both these numbers by 5. 5 divided by 5 is 1. 40 divided by 5 is 8. Each student gets 1/8 of a pizza, which makes sense. Pizzas are usually cut into 8 pieces. So you realize each student only gets 1 piece of pizza, which for you guys is probably not enough. Okay, so it says, how much pizza will each student receive? They each get 1/8 of a pizza. Now, the second question says, what fraction of the pizza did each student receive? What fraction of the total pizza? Well, it's like this question up here. They get 1/40th of the amount of pizza because there's 40 students. So each student gets 1/40th of the total pizza, total amount of pizza. Okay, so 2 questions. They each get 1/8 of a pizza, 1 slice, but overall they get 1/40th of the total pizza. Okay, next question, we're almost done. Lillian has 2 2-liter bottles of soda. Okay, so if you think about that, a 2-liter bottle is how your parents usually buy it for a party. Okay, it's one of these. I can do that a little better. Oh, okay, you see it? It's a big 2-liter. That's usually what I call it, as a 2-liter. Okay, but she has 2 of those. So how much total soda does she have? Well, 4 liters of soda. So when I draw my tape, I know my total amount of soda is 4 liters. Now, which she distributed equally between 10 glasses. So my tape should have 10 parts on it. Okay, so each one of these boxes represents a glass of soda. Okay, how much soda was in each glass? Express your answer as a fraction of a liter. Okay, well, 4 liters is being divided into 10 glasses. So 4/10 of a liter in each glass. Okay, I notice I expressed that as a fraction of a liter, 4/10 of a liter. Or you could have simplified and said 2/5 of the liter. Okay, if you go to the next page, it's still talking about Lillian and her soda. It says, express your answer as a decimal number of liters. Well, remember in the warm-up today, I kind of talked to you about taking a fraction into a decimal, and this one's easy. If you have 4/10 of a liter, and it says write that as a decimal, well, 4/10 can be written as 0.4 because 4 is in the 10ths place. Okay. Then the next question says, express your answer as a whole number of milliliters. Okay, well, then ask yourself, how many milliliters are in a liter? Okay, there are 1,000 milliliters in a liter. And since I'm going from a big unit, a liter, to a small unit, I'm multiplying. Okay, I'll have lots of milliliters. So I want to take that 0.4 and I want to multiply it times 1,000. Okay, well, let's remember when you multiply, your digit gets bigger on the place value chart. Okay, well, how many places bigger? 3 places bigger. Those 3 zeros kind of help you remember that. I'll show you the place value chart. Miss Ballard, remember, kind of steps it off in the room. But if you have 4/10 of a liter and I want to multiply that by 1,000, remember that 4 gets 3 places bigger. So it moves up 1, 2, 3. It would move to the hundreds place, that 4. The 4 would move up there, so you can see the answer would be 400 milliliters. So that would be your answer for that one. 400 milliliters. All right, last question, almost done. The Caliph family likes to paddle along the Susquehanna River. That is a river in Pennsylvania. I grew up in Pennsylvania, so that's kind of neat. They paddled the same distance each day over the course of 3 days, traveling a total of 14 miles. How many miles did they travel each day? Okay, so what's being divided? The miles, okay? And when it says each day, that kind of gives you a hint. When it says each day, those are your boxes. The boxes on your tape represent days, because that's what you're looking for. So notice this is a day, and they want to know what goes in that box. How far did they go each day? Well, their total was 14 miles. So we just say 14 miles divided by 3 days would be 14/3. Okay, that's improper, so let's divide that out. 3 divides into 14 4 times, which is 12. So that would be 2 left over. So they go 4 2/3 miles each day. Now, this says, if the Caliphs went half their daily distance each day, so half of this, but extended their trip to twice as many days, okay, their trip was 3 days. Well, if they extended it and made it twice as many, times 2, 3 times 2, 6 days, how far would they travel? Well, if I take 4 2/3 and it says they're going half that distance, okay? Well, think about that. You can think of a number bond if you want. 4 2/3 if I'm gonna split that in half, well, 4 if I split it in half would be 2 whole. 2/3 if I split it in half would be 1/3 and 1/3. Okay, so half their distance is 2 1/3. But they're extending their trip to twice as many days, so that would be 6 days. It says, how far would they go? Well, 2 1/3 for 6 days. So if you think about listing 2 1/3 6 times, notice that means you're going to have 6 2s and 6 1/3. 1, 2, 3, 4, 5, 6. Okay, so 6 2s, 2, 4, 6, 8, 10, 12, 12 whole. And you have 6 1/3, 1/3, 1/3, 1/3. That's 1 whole, right? 3/3, there's 1 whole. 1/3, 1/3, 1/3, there's another 1 whole. So that's 2 whole. Notice they would go 14 miles, which is the same amount as up here. So if they go half the distance, but twice as many days, they're still going the same distance. All right, that's it for today, guys. Hope you followed that okay. So you can just go on and try the homework. See you next time.